Hello, good day viewers. Welcome to third class, a solution to all the problems in class as far as science subjects are concerned. Please, if this is the first time to visit us, consider subscribe and click on the notification button so as to be notified every time we upload a new video. And please like, share and comment. Alright, in this video tutorial we are going to be looking at Surds. So we are going to look at the introduction. Surds. Now, what are surds? That is the first question we are going to look at. But then before we got that, we should all know that surds are just numbers like any other numbers. Now, from numbers, we have what we call real numbers and imaginary numbers. Now, a surd is not an imaginary number. A surd is a real number. Now, under real numbers, we have what we call rational numbers and irrational numbers. I can give it this one. Irrational numbers. Now, still under this is where we have the surds. So since a surd is a real number, is under real numbers, so it means we're not going to talk about imaginary. We are just going to look at real numbers. And under real numbers, where we have rational numbers and irrational numbers. Now, let's first know what rational numbers and irrational numbers are. A rational number is a number that you can express. Is a number that you can express, or that one can express. You can express as a ratio of two integers. As a ratio of two integers. That is to say, any number that can be made in form of a fraction is what we call a rational number. Now, examples under rational numbers, we can have something like 2 over 5. This one is a rational number because it is in a fraction form. So it can be expressed as 2 to 5. So this one becomes a rational number. And then we have 3. 3, any whole number is a rational number because it can be as well expressed as 3 out of 1. So this one is also a rational number. A number like 0.5 is also a rational number because this can also as well be expressed as 1 out of 2. Then 0.2 is also a rational number. 0.2 is also a rational number. Can be expressed as 1 out of 5. So those are some of the examples of rational numbers. Okay, now how about irrational numbers? Irrational numbers. Now, an irrational number is a number that cannot be expressed. Is a number that cannot be expressed. A number that cannot be expressed as a fraction and has an ending decimals. A number that cannot be expressed as a fraction now. Under irrational numbers, we are going to look at numbers which, when we put them under root, their product has an ending decimals. Now, examples under this will be the square root of 2. The square root of 2 is an irrational number. Why? When you press on your calculator to find the square root of 2, you'll find that it will give you figures like 1.4142 continuous. So it does not end, it does not have limited decimal places. So that one automatically makes it an irrational number, and in that case it becomes hard for one to express this as a rational number. There's no way you can get this as a fraction. It is very hard because its decimals are unending. Then another example is cube root of 5. This one is also an irrational number because it has gotten values which are, its result has an ending decimals. If you press in a calculator, the cube root of 5 is going to be 1.7099. It continues. So in that case, this can't be expressed as a fraction, and that makes it an irrational number. Then we also have other irrational numbers like e and then pi. These ones are irrational numbers, but they are not surds. These ones are the only surds. Now, from these two so far, let's first find the definition of a surd. From those two definitions, I think we can come up with a surd as a surd can now be defined as the square root is the square root of a number or numbers of a number that cannot be simplified into a whole number. Surd is the square root of a number that cannot be simplified into a whole number. Or rational. number. Now, it means in all cases, any figure, any term, any number that we see can be expressed as a whole number or as a rational number. That one becomes a surd. So the reason as to why we said a number that can't be simplified as a whole number, it means, for example, if we have the square root of 4, this one is under root, but its term in here can produce a rational, because the square root of 4 is 2, which can as well be divided by 1. So this form here is rational and it is a whole number, so this one does not become a surd. But a figure like this, it remains that way. There's no way you can have it in this format, so that makes it an irrational, a surd. Okay, now let's look at the types of surds. What are the types of surds? We have very many, but I'm just going to mention a few. The first one is pure surds. Pure surds. Now, pure surds, this is where we have only one real number put under root. That is to say, this one is a pure surd. The square root of 3 is a pure surd. The square root of 5 is a pure surd. The square root of 7, like that, continues. These are pure surds because they only have one rational number that is put under root. And then the next type of surds is what we call a mixed surd. Now, mixed surds, for it has gotten 2 rational numbers, but one of them should be under root. That is to say, for instance, this one is a mixed surd because it has gotten one real number here and an irrational number, or a surd. So this one becomes a mixed surd, for it has gotten 2 rationals, one of them which is a whole number and the other one being an irrational. So that one makes that to be a mixed surd. Another example can be given this way: the square root of 5 and a square root of 2. This one is also a mixed surd because it has gotten 2 rational numbers, though they are all under root. And then the other example I can talk about is binomials. Now, under binomial, bi means 2, so it should consist, that means the term should consist of 2 surds. That is to say, the square root of 2, let's say, plus the square root of 3. This one is a binomial surd because it has gotten 2 surds in it. And then trinomial. This is now where we have 3, that is to say, square root of 3 plus square root of 2, let's say even square root of 7 or something like 5, something like that, anything, as long as it is a surd. This one becomes a trinomial. And then the last thing here is what we call a conjugate. The last thing I'm going to talk about is a conjugate. Now, if we have a surd, let's say the square root of A plus the square root of B, its conjugate will be the square root of A minus the square root of B. In that case, we only change the signs in between them. That is to say, if it was square root of A minus square root of B, its conjugate would be the square root of A plus the square root of B. So we change the signs. The conjugate of this is this. The conjugate of this is this. So in any case, if you have, let's say, a figure like 2 to the square root of 3 plus 4, and they tell you to find its conjugate will be 2 to the square root of 3 minus 4. Simple. No juju, anything here. As long as you've changed the sign in between, you make the conjugate of a surd. Now, let's look at the rules. The rules that we follow under surds. I'll begin with the rules of addition. Under addition, if any surd is given, let's say A to the square root of B plus C to the square root of B, A to the square root of B plus C to the square root of B, as long as what is under root here is the same, you only add this and follow it by that. So it means here you look for the common factor, you put it outside the brackets, and then you add these ones. So A plus C, and then close brackets, you multiply it with this common factor here. Let's say if you have, for example, if you have 2 to the square root of 3 plus, let's say 3 to the square root of 5, here it will produce 2, rather this should be 3 also, sorry for that, this should be 3. So this will produce 2 plus 3, and then outside we shall have our the square root of 3, which will be the same as 5 to the square root of 3. As simple as that when we are adding. And then if we have these terms into the under root, the ones which are under root, which if they are different, let's say we have A to the square root of B plus C to the square root of D. In this case, this term remains the way it is. Please don't add figures of different, terms of different surds. Here, this one, as long as it is different from this, you just leave it the way it is. Don't temper with any. There's no term here. This one remains the same as this. C square root of D. Let's say if you have, for example, this is number 1. So, number 2. So here, for example, if you have 2 to the square root of 3 plus now 3 to the square root of 5, like I've done it there, this one will remain as 2 to the square root of 3 plus 3 to the square root of 5. It does not change because the terms or the numbers under root are different, so you don't do anything on that. Okay, so when it comes to subtraction also, we have A to the square root of B minus C to the square root of B. We also do the same as long as under the roots are the same. So we just put the A, which is here, and might subtract the C, and then put them, multiply them by this term which is outside. That is to say, if we have a value, let's say 2 to the square root of 5, minus 3 to the square root of 5. As long as these terms are the same, here we are going to get it as, shall get it as 2 minus 3, then we put them under the root of 5, which will be the same as negative 1 to the square root of 5. And I think you all know how we can write this, because this is the same as a negative. Now this one will be this. Yeah, if you put it this one, this, they are all the same, no problem. Okay, the next thing is how about when you're multiplying? Now the rules under multiplication will be if a term A is multiplied with B, this one is the same as A times B. You put them all together under the root. So that is, say, if you have the square root of 2 times the square root of 3, this will be the same as the square root of 2 times 3, which is the square root of 6. That is how multiplication goes. Or if you have A the square root of B times C to the square root of D, this will be equal to, you get these ones, multiply them together, so A times C, and then put under root B times D. So you get this and this, multiply them together, and then this and this, also put them here. That's what happens when we're multiplying. That is, if you have 2 to the square root of 3 times 3 to the square root of 5, this will be the same as 2 times 3, then under root 3 times 5, which will be the same as 6. It will be the same as 6. This will be the same as 6 to the square root of 15. So that is how we shall deal with multiplication. Now, how about if we are dividing? If we are dividing, if a term A is divided with B, this should be written as this. That is, say, we put them all under one root and then divide them. So if you have, for example, the square root of 8 divided by the square root of 2. By the way, did you know that if you decided to leave it this way, you do not come up with you do not end up with any correct answer. It will remain that way. But if you do it this way, you will have now 8 being divided by 2. And remember, 8 divided by 2 is your 4. And the square root of 4 is 2. So in this case, this one can be solved easily. But if you leave it this way, there's no way, because you will not get the square root of 8 and you will not get the square root of 2. So that is another trick. I think that is all for today. Please consider to subscribe and leave your comment in the comment section. Give us a like, and thanks for watching.